Welcome to Beginner Sensors for Heat Transfer. In last video, we discussed modeling. In this episode 4, we are going to discuss meshing, boundary conditions, and loading. Let's go to ANSYS. First, we will do meshing. Look for meshing under preprocessor. Click meshing. Before meshing, we have to set default mesh attributes, that is which material, element and real constant we want to mesh with. Click on mesh attributes, default attributes. In pop-up window, define each option carefully, that is element type, material model and real constant we want to use. I will first define default mesh attributes for brick area we are going to mesh. In this case, we only have one element, that is plane 77. Material number 1 for brick as we discussed in episode 2. So I am going to select material model number 1. Remaining 3 are not applicable in this case, so I am going to keep it as it is. Click OK. Now our mesh attributes are set. Look for mesh tool under meshing. Click it. In pop-up window, select each option carefully. First, select area. Select smart size. You can change smart size from here. I'm going to set it 5. Select pre-meshing. It is already selected. There is one more option, mapped meshing, which is advanced. We will not discuss it here. Everything is set. Click mesh. Pop-up window is asking to select area to be meshed. Select area representing brick. Click OK. Area representing brick is meshed. In mathematical terms, we have discretized the domain. Similarly, I will mesh area representing concrete. Only difference is in mesh attributes. I will assign material model number 2 for concrete as we discussed in video 2 instead of material model number 1 for brick. I will skip illustration for concrete and move to boundary conditions and loading. Now that we have meshed both brick and concrete area, we are going to do boundary conditions and loading. Look for loads under preprocessor. Click loads. Define loads. Apply. Thermal. In this problem, only convection will take place for heat transfer. But if you are dealing with other problem having different boundary conditions and loading, you can select accordingly, for example, temperature or heat flux. Coming back to our problem, we only have convection. Click on convection. On lines. First I will apply on outer walls. Select outer lines. Click OK. Pop-up window is asking to provide information about convection. Read carefully and fill in information. Apply film coefficient is constant in this case. Film coefficient value for brick as outside material layer is brick. I'll check quickly before writing it here. It is 0.012 BTU per second per inch square per degree Fahrenheit. Be careful, we have to be consistent with units and keep track of it because ANSYS will not keep track of it for us. I'll write film coefficient, that is 0.012 Bulk temperature is constant in this case, that is outside temperature 10 degree Fahrenheit. This is uniform convection, hence we will leave these two places blank. Click OK. You can see red arrows on lines here and here, indicates boundary conditions or loading applied on that lines. Similarly, I will apply convection loading on inside of the chimney. Only difference from outside condition is ambient temperature, that is 140 degree Fahrenheit, and film coefficient to be applied is for concrete, which is 0.037. I will skip illustration of that part. You can see convection loading is applied on both sides of chimney, indicated with red and blue arrows. I will change background to white for better visualization. Look for plot controls on top bar. Click plot controls, style, colors, and reverse video. You can see red arrows indicate convection condition on inside of the chimney, and blue arrows indicates convection on outside of the chimney. Thank you. This is it for this episode. In next episode, we will cover solve, convergence, and post process.